Hi there, guys. Today we're going to get real crazy and look at graphing linear and absolute value inequalities. I love a lightsaber. I'm so sorry that I'm such a dork. So it's a lot like what we've been doing, except just a smidge different. I know you can do it. So first thing we're going to do, I'm going to start off by just rewriting this inequality over here. Already. That's totally a 4. I'm going to rewrite it, except for this time I'm going to use an equals instead of an inequality because we know how to graph lines. I want to put it in slope-intercept form, always, always, always. So first I'm going to subtract x to get the goals eventually to get y alone, as you remember. So we've got 4y on the left equals negative x plus 2. To get y alone, I need to divide by 4 on each side, all the places. So I've got y equals negative, and I'm going to make this a little bit different and turn it to 1/4 times x. It's the same thing as negative x over 4. Plus, and then I can reduce 2 over 4 to 1/2. So now I know 1/2 is my y-intercept, so I can go up right between 0 and 1. And the slope is negative 1/4. So from here, I go down 1 to negative 1/2 and write 4. 1, 2, 3, 4. Now, before I connect these lines, I'm going to take a look back at the inequality. I can see here I've got a greater than symbol. If I have greater than or less than, my line will be dashed. If I have greater than and equal to or less than and equal to, my line will be solid. So for this particular occasion, we've got a greater than with no equal to, so our line will be this one here and be dashed. So I'm going to connect these points really poorly with a dashed line. Looks something like that. And then the very last part that everyone really likes to forget about is the shading. If I have greater than or greater than and equal to, I shade above the line. If I have less than or less than and equal to, I shade below my line. So in this case, whoopsie doodle, I don't know what that even was. In this case, I'm going to shade, since I've got a greater than, we're going to shade this part of the line of the graph above. So we're going to go here and we're going to shade all of that because that's where the solution set is. Okay. Pause the video, try the next one on your own. You can do it. Okay. So you should have first rewritten this little puppy in slope-intercept form. First part, subtract 3x from each side. Got 1/2 y is less than negative 3x plus 2. To get rid of y over 2, we're going to multiply everything on both sides by 2. So 2 divided by 2 cancels on the left. We're left with y is less than negative 6x plus 4. Now we need to graph this. We go up 4 for the y-intercept. And then the slope is negative 6. So we go down 6. 1, 2, 3, 4, 5, 6, and write 1. The less than sign without any inequality says that our line will be dashed. And then it's less than in this case. So we're going to shade below, which seems confusing because it's almost a straight vertical line. But we're just going to shade to the left there. All right, one more. Pause it. Do it on your own. Ready, set, go. All right, last one. We've got negative x plus 2y is greater than 4. Got to rearrange. So I'm going to add x to each side. 2y is greater than x plus 4. We divide everything by 2. and get y is greater than 1/2 x plus 2. Our y-intercept is 2. We go up 1, right 2 for our next point. To know it equals again, so we're going to use a dashed line to separate the coordinate grid. And it is greater than, so we shade above. All right. Now, we want to look at absolute value inequalities. So scroll on down and we'll do that. All right, so first things first, we're going to do just like we did before and rewrite this as an equation, an absolute value equation. Remember, we make a little table for these. That was the least straight line ever. It's all right. We're just going to make it work. When x is -3, plug -3 in to the absolute value x. Absolute value of -3 is +3, and 3 minus 4 is -1. Do the same thing for -2. Absolute value of -2 is +2. 2 minus 4 is -2. For -1, 1 minus 4 is -3. 0 minus 4 is -4. And then we kind of just reverse what we did for the next 3 points. 1 minus 4 is still -3. So now we need to graph this. 0, -4 is the point at the very bottom there. And then we've got -3, -1. And the next points that make that V. We look back again at the inequality. Same rules apply. This has a greater than or equal to. So that means our line is going to be a solid line. Ooh, that's a weird line. So we've got a solid line. And since the inequality is greater than or equal to, we're going to shade above. All right. Same idea as the linear inequalities. This time we're just have a different shape. So try the next one on your own. Scroll on down and do it. All right, so we're going to rewrite it again. Y equals 2 times the absolute value of x plus 3. We're going to plug some values in here. So if we've got -3, 2 times the absolute value of -3 plus 3. The absolute value of -3 is 3. So we take the absolute value away and just multiply. 6 plus 3 is 9. We can do the same thing. You just get rid of that. For -2. 2 times the absolute value of -2 plus 3. The absolute value of -2 is +2. So 2 plus 2 is 4, plus 3 is 7. Do it again for -1. 2 times +1 plus 3 is 5. Put 0 in there and we just get 3. With 1, 2 times 1 is 2 plus 3 is 5 again, and 7 and 9. Now we can only plot a couple of these points on this graph, but we'll be able to get the idea. I know we can plot -1, 5. So 1, 2, 3, 4, 5. 0, 3. And 1, 5. Everything else will be off this coordinate grid, but we get the idea. This is a solid line because of the inequality having an equals underneath. And then we need to shade. It's less than, so we're going to shade everything below. Okay. One more. Scroll down. Try it on your own. All right, last one. Let's rewrite it as an equation instead of an inequality and plug in some values for x and find y. So -3 we plug in, we have absolute value of 3 times -3 plus 1. -3 plus 1 is -2. absolute value of -2 is +2. 3 times 2 is 6. So you may have noticed I did all the algebra inside, all the adding and subtracting and multiplying and all that needs to be done inside the absolute value first. And then I multiplied it by the 3 on the outside. Let's try -2. I have y equals 3 times the absolute value of -2 plus 1. -2 plus 1 is -1, and the absolute value of -1 is +1. 3 times 1 is 3. We can do the same thing for -1. -1 plus 1 is 0 times 3 is 0. Put 0 in there. We get 0 plus 1 is 1 times 3 is 3. 1 plus 1 is 2 times 3 is 6. 2 plus 1 is 3 times 3 is 9. 3 plus 1 is 4 times 3 is 12. We can't graph all of these again, but we can get an idea. -1, 0 is going to be the point. 0, 3. Ooh, that's loud. And -2, 3. This is a solid line again because of the equals in our inequality. And it's greater than, so we're going to shade this little section above. All right, that's all you need to know about graphing linear inequalities and absolute value inequalities. Continue, be fantastic, take care of yourselves. I'll see you tomorrow.